Hi, welcome to my channel pibyme Maths. This is WMA11. Here we are solving January-February 2019 Pure Math 1 paper. Let's look at question number 1. This is from integration. So first write it as 2 over 3 x cube minus 1 over 2. Put the x cube on top. It becomes x power minus 3 plus 5. Now we integrate it. 2 over 3 times x cube becomes 3x square. Half x power minus 3 becomes, we are integrating it, so it's going to be x power 4 over 4. X power minus 3 plus 1 over minus 3 plus 1 plus 5x plus c. So it's going to be 2 over 12 is 1 over 6 x power 4. Negative times negative positive 1 over 4 x power minus 2 plus 5x plus c. That's all. It's just one easy 4-mark question. Question number 2. You have an equation given. Find y as a simplified function of x. The trick here is to write everything as a power of same base. You have 3 power x divided by 3 power 4 y is equal to 27 is 3 cube. Square root of 3 is this, right? You put this on top, it's 3 power x minus 4y is equal to, here you can add the powers, right, by using laws of indices. So 3 plus half is 7 over 2. Since the base are same, the power should be equal also. And make y as a subject. 3 x minus 7 over 2 is 4y. Therefore, y is equal to x over 4 minus 7 over 8. Question number 3. The line L1 has this equation. Find the gradient. That's one easy one. Make y as a subject. So, 5y is equal to minus 3x plus 7. Y is minus 3 over 5x plus 7 over 5. The coefficient of x is the slope. Therefore, gradient is equal to minus 3 over 5. Part B now. Line L2 is perpendicular to L1. So, the slope of L2 will be negative reciprocal of the slope of this. And it passes through this point. Take the point as x1, y1. So, y minus y1 is equal to slope times x minus x1. Or you can use y equals mx plus c also. So, y is 5 over 3x. When you multiply these two, you're going to get 30 over 3 is 10 minus 2. Minus 10 minus 2 minus 12. That's another 3-mark question. Question number 4. A diagram is given. The question says figure 1 shows a line L1 with the equation 2y is equal to x. And then the curve with the equation y is equal to 2x minus 1 over 8. This one y is equal to 2x minus 1 over 8x square. The region R is shown unshaded in figure 1. As you can see here, it's unshaded, this one. And bounded by the line L1 curve and the line L2. There is another line L2. Okay, we don't know the equation of this line actually. So we need to find the x-intercept of the curve by using this equation. So you can get the equation of this dotted line, right? So given that L2 is parallel to y-axis, passes through the intercept of C with positive x-axis, identify the inequalities that define our. First I'm going to find the x-intercept of this. 2x minus 1 over 8x square is 0. So multiply through it by, let's just take x as a common factor. 2 minus 1 over 8x is 0. So we'll get x is equal to 0, or 2 minus x over 8 is 0. X is equal to 16. Therefore, the equation of line L2 is x is equal to 16, right? Now we need to define the inequalities. Always remember, when the shaded part is below or on the left hand side of a vertical line, or below the line or below the curve, you need to use less than or equal to. This is for solid line, this is for dotted line. If it's shaded, if it's shaded above or right hand side, and we are defining the shaded region using the inequalities, you need to use this. But in this case, the region is unshaded. So we need to use the same rule with unshaded part actually. So if unshaded is below or left, you use this. Unshaded is above or right, you use this. So let's look at the graph now. Let's take this line. The unshaded region is below the line. So it's a solid line. So 2y is less than or equal to x. And then look at this line. It's a dotted line and the unshaded region is left hand side. This is x is equal to 16. So x is just less than 16. It's a dotted line, right? And for the curve, it's shaded above the curve. So it's a solid curve. So y is greater than or equal to 2x minus 1 over 8 x squared. But using these inequalities, you can shade this region also, right? You can shade this region also. You see below the line, above the curve, left hand side of the dotted line, right? But there are two regions. We are particularly talking about this region. So you can write, instead of just 0 less than 16, you can put it as 0 to 16. X has to be positive. That means from here to here. So we don't consider this region. Okay, that's a proper inequality actually. Question number 5. We have a curve given. Figure 2 shows a plot of part of the curve with the equation y is equal to cos 2x. Okay. The x is measured in radians. Now, state the coordinate of P. Where is P? P is here. Okay, when you compare it with the original cos x, the cos x is this. In radians, this is pi over 2. This is pi. So the point P was here. It's pi comma minus 1. But when you apply this transformation, you need to divide the coordinates by 2. Divide the x coordinates by 2. So it's P of pi over 2 comma negative 1. Just mention this, you will be given 2 marks. Part B. A copy of figure 2 is given. On top of this graph, sketch y is equal to sin x. To sketch this, first of all, you need all these units first. In cos x, the units are, if you take cosine graph, it's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2. You need to keep on adding pi over 2. But this graph given here is cos 2x. So you need to divide the x coordinates by 2. So you need to start from pi over 4 and keep on adding pi over 4. That's the trick here. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay. Now we know that when we want to sketch sin x, we have to start at origin, goes to pi over 2, intersect at pi, intersect at 2 pi. This will be the sin x. Y is equal to sin x. So you have to mention the points. This is 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, which is 3 pi. So you don't need to mention all these points actually. Here make sure it passes through pi. That's a graph. You will be given 2 marks for this. Part C now. Hence or otherwise deduce the number of solutions to this equation. Basically they are talking about point of intersection of these two in this interval. So we are going to look at the interval from 0 to 2 pi and find the number of solutions. So from 0 to 2 pi, this is 0, this is 2 pi here. So you have 1, 2, 3 points of intersection. There are 3 points of intersection. So when they say 20 pi, you can divide them into 2 pi, like 10 portions, right? So in one portion is a 2 pi interval. You got 3 intersections. So you can just write 10 times 3 is equal to 30 solutions. So here we know 0 to 2 pi is 30 plus 20 pi, 0 to 20 pi is 30. 20 pi to 21 pi is same as finding the point of intersection from 0 to another 1 pi. So you have another 2. So you can write it as 32 solutions. That's all. Question number 6. You have a function given. Solve the equation f dash of x is equal to 0. So differentiate it. You will get 2 times 5 over 2 x power 5 over 2 minus 1. 40x becomes 40 is equal to 0. 2 can be cancelled. 5x power 3 over 2 is equal to 40. X power 3 over 2 is 40 over 5 is 8. So x is equal to, you put the power other side, becomes reciprocal. 8 power 2 over 3. 8 is 2 cube. So 3 will be cancelled. 2 square is 4. That's all. Just an easy 4-mark question. Part B, solve the equation f double dash of x is equal to 5. We know f dash of x is equal to 5x power 3 over 2 minus 40. Now we differentiate it one more time. So it's 5 times 3 over 2 x power 3 over 2 minus 140 becomes 0 is equal to 5. So x power 3 over 2 minus 1 is half. 5 can be cancelled. 3 over 2 goes to the other side. This. Square both sides, x is equal to 2 square over 3 square. That's now the 3-mark question. Question number 7. Figure 3 shows the design for a structure used to support a roof. The structure consists of 4 wooden beams AB, BD, BC, AD. Okay. Now, AB is 6.5. BC and BD are 4.7. This is 4.7. This also 4.7. BAC is 35. Find to one decimal place the size of the angle ACB. They want us to find this angle. This angle. One angle opposite side, another angle opposite side. We can use sine rule. In degree, so you can write it as sine ACB over 6.5 is sine 35 degree over 4.7. So ACB is equal to sine inverse of 6.5 times sine 35 degree over 4.7. So let me calculate this. Make sure the calculator is in degree mode. 6.5 times sine 35 degree divided by 4.7, and then sine inverse of this answer 52.489, etc. Okay, now listen me carefully. Usually this is like an old paper, 2019 paper. Usually in the recent papers, they will mention whether the angle is acute or obtuse. Okay, because when you apply sine rule, you will have this issue. You might get an acute angle, but they might want you to find the obtuse angle. So you just put 180 minus. But in this case, if let's say this angle is 52 degree, for example, this is 52. This is 180 minus 52, right? So 180 minus 52 is 128, right? If this is 128, this isosceles triangle, this also going to be 128. That's not possible because in a triangle, all the angles add up to 180 degree, right? So here, just adding these two angles already becomes 440, 456, 256. So that's not possible. Something is wrong with this angle, because the angle should be obtuse angle. So you need to write therefore ACB is equal to 180 minus 52.48 and write the answer. They want the answer to 1 decimal place, 127.5 degree. Let's look at part B now. We know this angle is 127 point something. So this is going to be 180 minus this. That's going to be 52 point something. Since these two isosceles triangle, this also 52 point something, right? So the value was, I stored it as A actually. So 180 minus A, 52.4, right? I'm gonna store it as B first, okay? So this total angle will be 180 if you consider this triangle, the whole triangle. The angle at B is 180 minus 35 minus this. So I'm going to apply the sine rule now. The whole length AD over sine angle at B, which is 180 minus 35 minus 52 point something. 52.48, that's true, is equal to 2.48. okay, so one angle opposite side, another angle opposite side. We know this side is 4.7, so 4.7 divided by sine 35 degree. So we can calculate AD from here. So I'm gonna write it as 4.7 times sine 180 minus 35 minus 52 point something. I stored it as B divided by sine 35, 8.186 dot dot dot. That's the total length of AC. Okay, so to find the total length of wood, is equal to 6.5, that's this one, 4.7, 4.7, and the one we just calculate, add everything. So plus 6.5 plus 4.7 plus 4.7. They want the answer to the nearest meter. Okay. What is the measurement given here? All of them in meter. So you're gonna get the answer as 24.08 etc., which is 24.1 meter. But they want the answer to the nearest meter, so write it as 24 meter. That's all.